that too with 4 different scenarios. So we'll just go through once. We'll have an overview of all that stuff, and then we'll see what is a system call and how is it different from function call. That part we'll discuss. Okay. So last session, first we studied about this standard OS model, that which is collection of software and hardware. Software deals with applications and operating system, and hardware is all about CPU, RAM, and 3. And layered representation of operating system that has operator or user program, IO management, device driver, memory management, process management or allocation, hardware. These are the things related to layered representation of OS. Layered representation of OS. So 2 things you can say now: software and hardware for standard OS, and layered representation. These all things will come into picture. Exactly keeping this process in view, we discussed about the architecture of OS. Here I covered last session architecture of OS, applications provided for user space, for kernel space, then system call interface, and from then we have all these 6 tasks that which are going to do by OS: memory management, process scheduler, inter-process communication, then file system, and all that stuff, and network manager, and all these 6 tasks. We haven't studied any of these. I just have come up with only architecture of how that we are going to deal with. And one other basic structure of your OS deals with hardware, kernel, shells, and applications. Every OS will have the first layer as hardware. Every machine will have first layer as hardware. Over it will have kernel, and then on which your shell is generated, and then applications, utilities or applications. Let's see. So we studied about last session with standard OS architecture. Okay. Standard OS model, layered representation of OS, architecture of OS, and basic structure of OS. These are the things we studied in my last session. Now we are going to see today what is system call, and then we find what is a function call. What is system call and what is a function call? These 2 things we'll cover today. So based on this process only, and after completing these 2, we will find what is the difference you notice. Individually we'll talk first, and then we'll see what is the difference between system call and function call. Three things. In general, you can say if the very first to say what exactly a system call is, you can say system calls provide something called trams. running on a computer. Running on the computer. That is, you can say, an interface to talk with the operating system. That's what I mean. And what exactly it means? See, operating system provides one way of communication, direct, and few things are there over a computer where you cannot, or OS cannot directly make interaction to it. So in between, you need to have some programs. You need to have some programs. Let me just give you a small example. Say, for example, your system, it's connected with the CD-ROM. Let's call DVD. DVD drive is it's there on the machine. DVD drive is attached on a machine. And now you can say not only this DVD, even it can be your, something like you can pen drive is an external device. That is also one external device. DVD-ROM, though it is attached, but on a system. A floppy disk, where floppy will be placed on an external device, external disk, right? So these all are I/O device. I mean, so for those all external devices, I/O devices, input/output devices, to communicate with them, you cannot have direct interaction with them. You don't have permissions to directly interact with them. So is the reason OS is going to take support of what now? System call. System call is also one program only. It is also one program. So that program will make a communication with what now? External devices, which directly we cannot communicate through external devices. Those things will be covered, or those things will be asked. So let me just give a small brief idea of it. So I can say, when a program needs to ask for a service for which it does not have permission, for which it does not have permission to do that by itself. Then what will happen? From the kernel, which is the heart of OS, it uses what? System call. System call. So simple as the task, you can say. User level processes, whichever you are asking for. Those which I took example. No, any external device, you can say. Any external device. So user level process do not have what now? Same permissions as the processes directly interacting with the OS. For example, you can say, to communicate with the external I/O device, or to interact with any other process, what will happen? A program uses what? System calls. Important thing to understand is, system call is also one program, part of kernel. part of kernel. So kernel is a program, and through that kernel we have system calls. Those system call programs will be helpful for us when you want to communicate with external IO devices. You hope you remember in my last session when I was saying, I said system call interface. To do all these things we require system call interface, where it is part of kernel, first kernel, from then system calls. And you see these all activities are being done by system calls, right? Exactly same way when you talk about function call, this is something related. You can understand it through a programming language, or you can understand only for understanding, I'm saying. But otherwise OS has even a concept of what functions. OS even deals with what. So what is a function now? A general point, you can say a function call is also called as subroutine call. It's also called subroutine call. And what is subroutine? A subroutine also known as we got all these things. Either it may be a procedure, or it may be a function, or it may be a method, or it may be a routine. These all things will be a part of what subroutine. What do you do with this? Is part of a larger program. Larger program is responsible. That is responsible. Responsible for what? Carrying out a specific task. Responsible for carrying out specific task. Specific task. What specific task? It may be anything. For you may ask it to do some specific, sort of job, where you may ask to interact with so and so device, or you may ask it to, once the task is over, it should return back again. It should return back again to continue the process. Let me just give you some idea on what exactly the process, the function, the programming, the way function works. Exactly to that, even function call program will work now. So function call of OS will work. Normally, I said like it is subroutine. No? Say for example, according to your C programming, I create one function. I create one function called main, and in that main, we'll have some code for execution. Your specific task goes here. Specific task goes here. And same way, if I call one more subroutine, let's call B. This is also one function according to C programming. Same way, you're going to have specific task even in this block. Going to have your specific task. Now, whenever you call a function, first control will go to that specific block. Will go to specific block, And when control goes to specific block, control has been shifted to the block. That also, right? Because what is the main aim of it? What is the main aim of it? So simple, you can say the main aim of writing a function or calling a function for executing or performing specific task could be one reason, that you can have something called reusability. It's called what? Reusability. It provides reusability, code reusability. So whenever a function is called, what will happen? Definitely processor will go now. Processor will go to the code where actually the function, the code is, that particular code is residing, the function is residing. Function is residing. And execute the instructions of the function one by one. All the instructions of that function it will execute one by one. And once the task is over, it will return back exactly to the location from where it has shifted. So it shifted from main, from this line to this line, below, from the line from where from previous line was executed. So it will come to function, again the same process will happen, return back, it will hold an information that it should go back there, then again it will call C function, the C function is executed. Do you understand? And one more thing, especially in a case when B block is working, it means that A and C are like in the form of disabled, like they're not going to interact. Whichever function calls, only that function will have what? Execution. Do you understand? So what does it mean? What exactly does, let's say here, what subroutine does now? A subroutine perform a simple task, which is independent of remaining code, right? And one more thing, a function is coded in such a way that it may be called for, I said, multiple times and from different places. Simple as a task, code reusability, I said. Other different places in the sense what? What does it mean? As you find in our example, I'm calling A, B, C functions from main, or I can call B from A and C also from A. Main is calling ABC, na? Main is calling ABC. Same way, A can call BC, B can call AC, and C can call AB. Or one other point, there is a facility where you can call a function within itself. That's what the concept comes of recursion. Do you understand? Recursion. This facility also, we have a support for what? Functions that which can be a part of OS. So different places. So even what do you say now? Within other functions. Then what will happen? Whenever a function is called, see what will happen. Function is called. processor may go to where the code for the function is residing. And what it will do, and execute the instructions one by one. That is what I said. Whenever it goes, instructions one by one, executes one after the other, I mean one by one. Do you understand? One by one, I said. Once execution is over, what will happen? Once execution is over, it will return back. It will return back. Where it will return back? Exactly where it left off. Return back exactly to the location where it left off. Or exactly to the location from where it has come. It has come to the function. It has come to the function. And what it will do now? Remaining steps will be executed. Remaining steps will be executed. Do you understand? And one other important thing that you find is functions. I said no, the main purpose of function to have what? Code reusability. Main purpose. You can say functions are mainly used since it provides code reusability. This is one more task. And as I said you that this is comparatively, you can see, as I said, C programming is one example I said, where it provides a support of functions. And that functions is, you can see, whenever a function is called, control will jump from there to a block, that code is executed, and then once that code is over, it will return back again to continue the remaining functions, and then again control will go to B block, and from then it will go to, then again it will return that main, and then from there you can see that it will come back to C block, and that C block is executed. So almost all programming languages will support code reusability. You understand? So maximum is, you can say, like, many programming languages supports functions. And what do you call? A collection of functions we call as library. Best example to understand this, same example you talk about, same example. These all are my blocks, user defined blocks containing some code in it to get processed. Similarly, normally in this programming language, if you are aware of C language, you write in every program, you write something called hash include, something called as stdio.h. Hash include, we write something called conio.h. What are they? They are nothing but, you call them as header files. What these header files consist of? Something called functions provided by what? Software. So is the reason what you call library functions, because they are arranged exactly the way the books are arranged in library. All input-output functions in one block, all screen-related functions in one block, and all mathematical function block, all graphics functions in one block. You understand? So there is the reason what I said. All function or a collection of functions is called what? Libraries. Right? So these are the things that you could find a difference between function call and what? System call. And here a very clear point I gave. A subroutine, also known as I said procedure, function, method and routine, I said no. So it actually, these are all terminologies that we use. So if it is C language, you call function. In normally, if you go to this database related softwares, they provide something coding process through procedures. And if it is something you have idea about OOPS programming languages, if you have, they also support to have things by designing a class. That class will have method will have actions to be executed one by one. Functions related to C language. Procedures related with database softwares. Few programming languages even has a subject concept is there, but normally when I say a procedure, it's something function call. So you can say call is a call to a subroutine built into the system, whereas function call is a call to a subroutine within a program. Right? Same way as function calls are to perform with code to specific code for specific task or to perform with code for specific task. Same way system call is also a program, you can say a program. What for it is? Need to perform some task, perform certain for those devices for which it does not have permission. You understand? In the same way, you can even call, then you can say system calls is an entry point into the OS. Okay, our entry points, you can say. Clear now? And what more you can say with the difference of these two is uh, you can say system calls. It is what now? Portable. And what the kernel mode? Compulsory. You can say like why function calls are direct execution, na? Function calls are directly executed. And what about this one then? As you can say performance of system call is more because the execution process has to under under what kernel. There is no, you cannot say like system call can directly go. No, kernel should say kernel space system call should happen from that called block, from that calling block to called block. And if it is available, the code, even one line is there, it will go with the execution of that code. If you have like multiple lines of code, then it may go with repeated execution of that code. So it depends on how you make use of it, how you make the way you approach it. And even if you discuss other points of it, you can say like system call, it's not your task. You're not involved in. System call is like, especially when you start interacting with your external hardware components, automatically system call will become it will make an interaction through system call, especially when you make interaction with what external devices. We don't say like it should go with this system call for execute. No, we are not supposed to do all that stuff. It's all happens automatic. But what about function call? Function call doesn't have all that. So function call have direct execution. We don't have in between any one to execute a function. You understand? Here I said, na, go through this, you understand. Just see this. System call interface space, system call. What about user interface? Definitely no. We don't have anything called kernel to use for system related things. You have something called direct interaction. Search for the block, hit it, execute it. That's it. Do you understand? So undergo with what now? Kernel process. What about function? Okay, in that only, in this difference only we'll write. Function call will be called for execution in mode or user space. You understand? In user mode. Another thing, if you say, if you differentiate them with respect to execution process, I was talking about performance. Who will take more time? Who will take less time? You understand? So you can say one other difference has like system calls are executed where here in the architecture under kernel address space or under kernel executed under what is it called user space. User address, that makes a difference. Last topic of what overview of operating system. It makes a function call, where from it comes, and what is a system call, and how function call is different from system. What actually happens between these two? What are the differences, unities, all this stuff. Okay, is it clear? Now, keeping these things in view, probably in my tomorrow's class I'll start with the second part of this OS, where we are going to discuss what is a process, what is multi-program, how is it different from multi-thread, what is the hierarchy of process, so that you can analyze how these things will be just in your what working to process, multi-programming, multi-threading, multitasking. These all things will be covered now step by step, and they all come under the concept of process management functions. There are many things under this process management functions that even has a connection with your programming languages also, especially related to your C#.NET. You can focus even there also. Multi-threading, it's a part of Java, as well as it's a part of like even C#.NET. Multi-programming, multitasking. So first we'll understand tomorrow what actually the process we are going for. Then we'll see what is process model. First, related to process, we have lots of things to study first. And based on that, we'll discuss what are hierarchy implementation process. Okay? So we'll stop the session here and we'll continue with the next module. What is process management functions?